Good evening. Welcome to the QCIS channel. Where on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones. And this evening, I'm going to talk about something that a number of individuals really don't know about. And it's the ADA curb cut ramps. So those little ramps that you see at intersections when you come to major streets, they have a 2x4 plastic type structure and they have domes sticking up. Those are called detectable warning surfaces. Now, different states have different specifications. In Indiana, particularly in Indianapolis, most of your curb cut ramps have the slits before you get to the detectable warning surfaces. Now, when we go out there and inspect the curb cut ramps, we think a smart level. We must calibrate it. And there's a certain percentage that you have to come up with. Now, if you don't come up with that percentage, you use what we call a technical infeasibility form. Now, let's get into it. And let me show you what it's called, a TIF. This is the form that you use. And this is provided by the New Jersey Department of Transportation. This is known as a TIF. This form is utilized when the specification is not met. And the specification is usually at the top of the sidewalk. It must be at least, or we call it the top of the ramp, sidewalk, landing. We must meet a specification of 8.33%. And if we don't, we're going to have to fill out this form. And when this form goes back to a central office or wherever they keep the forms, there's going to be questions on this form. What happened? Why? Where did it take place? But this is what we call an ADA technically infeasible form. It has to be signed, photos. I just run it up and down and let you all know what it looks like. And I'm going to actually use this form because I do quality control for the city of Indianapolis when I go out there and inspect all of the ADA ramps. Now, let's go back again, share my screen. And I have something for you because when you are in any urban area, you're going to run into a lot of ADA ramps. And one thing that individuals don't know how to do is actually inspect these ramps. So I'm just going to take an old PowerPoint called ADA for Construction Inspection by NJ.gov Construction Management, dated January of 2019. And I'm going to go through this PowerPoint and explain to you how the inspection is done. First of all, we get down constructing ADA accessible facilities. Now, also, when you have ADA ramps, you also have your ped poles. Your ped poles are about 42 inches high. That's so people in a wheelchair can reach the button on the ped pole in order to activate the light. Or there's a countdown on the walk and don't walk. And when it gets to zero, after the ADA person or the handicapped person is actually released the button, be able to cross the street. Now, the reason why you have those going back to the detectable warning surfaces with those domes, it's because if a blind person is coming toward the street, they can actually put their stick down there. And of course, if they have good hearing, They know when they're reaching or they're at the street. Now, again, when we construct those ADA accessible facilities, current law of the land is what we call PROWAG. What does PROWAG stand for? PROWAG stands for Public Rights of Way Accessibility Guidelines. Public Rights of Way Accessibility Guidelines. And PROWAG guidelines must be followed. Now, there is an exception. Prior to letting an approved technical inquiry or technical infeasibility form should have been approved. Now, I just showed you what a technical infeasibility form was. Now, a note in the curb ramp details should be in the plans. Also, if it is determined after the letting, a curb ramp cannot be built as shown in the plans, here in Indiana, the area engineer should contact the NDOT ADA Technical Advisory Community for any inquiries. Also, the designer may also need to be contacted before the Technical Advisory Committee. Now, let's tell you about ADA ramps, and I've inspected a number of them. ADA ramps are not cookie cutter. Why? You have different types of ramps and every situation is different. So the contractor and inspection team should discuss the nuances of every ramp prior to construction. And the proposed design may need to be adjusted. Now, if adjustments are needed, the designer should be contracted. Correction, the proposed design, if it needs to be adjusted, and if adjustments are needed, the designer should be contacted. Again, the designer should be contacted, not contracted, contacted. Now, of course, there are NDOT standards, SS 604. Then you have your NDOT standard drawings. Now, this is just for NDOT, but I'm doing it based off of NDOT because I work for NDOT. They have their own forms, but basically the same active process. You have your design manual, just like Indiana, IDM 51, section 51-1. Then you have your Jiffy, and that's for what you need in the field. The Jiffy section 22 is just like our Pub 19 that we utilize in Pennsylvania. We call that the project office manual. As I move on, key elements. This is what you need to understand about curb ramps. What are the elements of a curb ramp? Well, when you deal with inspecting ramps, you have width, cross slope, running slope. Then you have your turning space. And then the turning space includes width, length, cross slope, and running slope. Then again, detectable warning surface, AKA truncated domes. So the domes that are sticking up. Then the gutter. When you measure back, you go from the gutter. We used to call it the algebraic slope. Well, they call it the counter slope here. And you measure in the gutter. Then your push button size, your placement, accessibility features. Again, going back to the gutter, you have your counter slope. Then you also have your construction and technical infeasibility. Now, here's what your curb ramp components in a pictorial form look like. Okay, you have your turning space. This is your ramp. Right here, this is your detectable warning surface. You also have flared sides, and you have your return curb. Now, curbs, some of them have reveals. Now, remember, like I said before, curb cut ramps are different. And sometimes you have to rip them out if they're not right. But you have your clear space, your detectable warning surfaces, your return curb. Generally, when it comes to your sidewalk, it's got to be a minimum of 4 feet. Now, that's one version. Okay, now, you must have tools for inspection. And right here, this is what we call a smart level. It's got a bubble, and I have a smart level. Now, what you get here, that's your percent. Now, let me be very clear when you go out here and inspect ramps with the smart level. Number one, there are two types of smart levels. Now, the specifications call for a 2-foot smart level, not a 4-foot smart level. Also, when you are going to utilize the smart level for slopes, you have to calibrate it. So that means you get a flat surface, and that surface must be equal, and you have to set the smart level to 0, and you have to put it on the percentage. Now, again, 2-foot smart level and straight edge, again, like I said, calibrate it. Also, you need a tape measure, or you could have a measuring wheel. Now, there is no construction tolerance for cross slope. Example, 2.01% is out of compliance for a 2% maximum slope. So what you do, you record largest values for cross slope, running slope, and counter slope after checking multiple locations to the nearest 100th of a percent. Now your ramp running slope, and this is what we're talking about when I told you about the 8.33. This is the running slope right here. Now 8.33 is the maximum running slope for a ramp unless the plans have a note that the technical advisory committee has approved a steeper slope. Now, anything that's above that 8.33 must have a technical infeasibility form. A technical infeasibility form. That means it's going to be built out of spec. Slope must be measured along the direction of pedestrian traffic. Running cross slope, 2% is the maximum cross slope for ramp unless the plans have a note that the TAC has approved for a steeper slope. Then you got to use a TIF, slope measure perpendicular to the direction of pedestrian traffic. Then you have your ramp and sidewalk length. Let me get this down here so you can actually see it. Bear with me. There we go. Your ramp and sidewalk width. Now, minimum ramp width is 4 feet. Exceptions to this are shown in the standard drawing. That's E604 SWCR series, where a minimum of 5 feet is required in order to provide a passing space. Now, of course, I'm doing all this via NDOT. Now, a 4-foot minimum ramp width is required. So if the ramp is wider than 4 feet, the ramp width may be reduced to achieve a minimum clear width of 4 feet to avoid an obstruction. Also, turning space running slope. And this is what it looks like. Again, here's your reveal on your curve. A turning space running slope, 2% is the max running slope for the turning space for ramp 1, is the cross slope for ramp 2. And that's what it looks like right there. The turning cross slope space or turning space cross slope also must be 2%. And that's the maximum running slope for the turning space for ramp 2. It is the cross slope for ramp 1. Again, all these are taken with a smart level. And then you have your turning space area, minimum clear dimensions of 4 feet by 4 feet. And this is all in the drawing specifications, but you can see the illustration that's been provided for you in this PowerPoint. Then you have your blended transition running slope and no sidewalk above the blended transition. Now, where a minimum 4-foot sidewalk width with a 2% maximum cross slope is above the blended transition, the maximum running slope of the blended transition may be 5%. And this is what they're talking about. Also, a 2% maximum running slope where there is not a 4-foot sidewalk above the blended transition, and you can see the standard drawings. And all this is utilized by the designers as well. But you have to know how to inspect it to make sure that the design is correct and the ramp has been placed according to specifications. Now, you also have what we call a detectable warning surface placement. Now, per standard, always extends a minimum of 2 feet in the direction of pedestrian travel. Extends the full width of a flush area entering traffic. So surfaces do not indicate directionality. They only serve as a warning for entering traffic. Again, see your standard drawings. So you see the extend a minimum of 2 feet in the direction of pedestrian travel right here, and also extend the flush area for entering traffic. And in this slope right here, here's your slope, but also this is your detectable warning surface placement right here. Generally, your detectable warning surfaces for something like this first illustration is 2 feet by 4 feet. Here you're using 2 feet and you're basically taking some 2 feet by 4 feet and you're making it into this radius right here. Also, you can extend the entire width of flush area for entering traffic. All right, detectable surface placement or detectable warning surface placement. In this illustration, the DWS is the entire width of the length and extends 2 feet in the direction of pedestrian traffic. This right here is telling you that the DWS is compliant. Now, both borders are greater than 2 inches. This ramp is not compliant. Now, if a border is needed, it can only encroach 2 inches from either side of the entry to traffic. Again, want more on that, you go ahead and see the standard drawings. And this is just not for Indiana. Every state has ADA compliance and standard drawings. And you must know how to read the standard drawings. Again, we're still on detectable warning surface placement. So if the distance between the backup curb and detectable warning surface is less than 5 feet, the detectable warning surface can be placed at the bottom of the ramp perpendicular to the direction of pedestrian travel. So if the distance is greater than 5 feet, then the detectable warning surface should be placed along the radius at the back of the curb. If this distance is greater than 6 inches, contact TAC. You're going to need a tip. And you see this right here, the bottom of the ramp, your curb radius. Prefer to follow the back of curb around the radius. 6-inch max between back of curb and front of DWS. And we're still on detectable surface warning placement. And where detectable warning surfaces are placed around radii by setting multiple plates. The minimum, again, that's the minimum and maximum truncated, and that's truncated dome spacing. Again, it's shown in the standard drawing, must be met. Contact tack if dome spacings don't meet the min and max requirements. And here's what the truncated domes look like. Some areas, they're yellow. Some areas, they look a little dark pink. But that's what the domes look like. And where multiple plates are used for a detectable warning surface, the blade ends should complete touch. No concrete should be visible between the plates. Change of grade. So if the change of grade is greater than 11%, then a 2-foot level area is required prior to the counter slope. Again, see the standard drawings. Now, the change of grade should be no greater than 13.33%. Okay, and you see how the running slope is being measured, smart level. The gutter, I call that the algebraic slope. That's the slope coming back from the gutter to the ramp. And then you have the 2-foot level area of grade, which is greater than 11%. And then you have the calculated change of grade. And that's where you get your change of grade, or again, some people call it the change of grade, some call it the algebraic slope, but when you add the running slope and the counter slope together, that's when you get your change of grade. Then you have your vertical surface discontinuities, and that's where the curb ramp meets the roadway. And when it meets the roadway, it should be flush. So no vertical discontinuities allowed. And you see this curb ramp is flush. Again, when construction of a new curb takes place, no lip should be present between the curb and street. This area should always be flush. No lip is allowed. Pedestrian signals and push buttons. Again, actuated, I already gave you the 42 inches, or say 42 and 48, and the unobstructed side must be 10 inches or less. Now, the actuator must be at least 2 inches in diameter with a tactile arrow. That's a tactile arrow for APS, and contrast with the housing. Fingertip push buttons are not acceptable. And this is what your push buttons look like on your pedestrian poles. Again, a clear space similar to a curb ramp turning space must be provided adjacent the push button assembly. Minimum dimensions are 4 feet by 4 feet, and the maximum cross slope and running slopes must be 2%. The push button clear space may overlap a curb ramp turning space. And where a push button clear space does not overlap a turning space, the push button clear space is subject to the same cross slope exceptions as the turning space, and that's noted in the standard specifications. Construction tolerance. No tolerance for ranges. Conventional industry tolerance for absolute values. Example, 0.2% slope means no more than 2%. 2.1 does not comply. 4-foot minimum width means no less than 4 feet. So 3.9 feet does not comply. 42 inches to 48 inches mounting height means no less than 42, no more than 48. And this is all in inches. Now, with construction, you have MOT. So when we deal with curb ramps, pedestrian MOT, that's maintenance of traffic. pedestrian MOT should be drawn in the plans. And you have to note crossing locations prior to actual closure. Again, pedestrian MOT should be shown in the plans, and you must note crossing locations prior to actual closure. Also, address vertical lip caused by milling/paving. And barricades should be a high visibility color, orange or yellow, be detectable by cane as long as the bottom of the bottom surface is 2 inches or less above the ground and the top of the top surface is 32 inches or more. That barrier would be detectable. And you must shield both work area and roadway. Now, again, from the MUTCD, of course, Indiana, Pennsylvania, a lot of the states, they have their own traffic control device manual, but it's all based off of the MUTCD. That's the Manual of Uniform Traffic Control Devices. And here's what the MOT for pedestrians looks like. You want to find everything in construction? Chapter 6. Here's pedestrian MOT. Pathway. Walkways should be 5 feet in clear width. If less than 5 feet, passing spaces of 5 feet by 5 feet for every 200 feet. And then you have your intrusion free. So pathway, all walkways should be 5 feet in clear width. Now, if less than 5 foot passing, then must have spaces of 5 foot by 5 foot or 25 square feet every 200 feet, and it should be intrusion free. Again, looking at the MOT, this is not a detectable barricade for pedestrian MOT. Detectable barricades for pedestrian MOT. This is what they look like. Then you have your audible information device. It's mounted on a vertical panel. Of course, when we deal with MOT, whether it's roadway MOT or pedestrian MOT, we deal with the surface. Now, broken, uninterrupted, or changes in levels. Well, surface is less than 1/2 inch max. So what happens is use ramp for broken surfaces, which is greater than 2 inches. Cross slope should be 2% max. Here you have your temporary ramps. Now, I just mentioned it, technical inquiry or infeasibility. So, when an element of the PAR can't be constructed in full compliance with ADA standards, a technical inquiry exists if an element of PAR can't fully comply due to an existing physical constraint, which makes it impractical within the scope of work. A technical infeasibility exists if an element of PAR can't fully comply due to an existing constraint that cannot be removed or adjusted. What I'm talking about right there, I just showed it to you. That's the technical infeasibility form that must be filled out if a ramp can't comply to standards and specifications. Now, again, if the plans do not accurately reflect the field conditions encountered, you're out in the field, you should work through the area engineer or your ACE and the designer to examine alternative solutions. Now, the ADA Technical Advisory Committee, and this is Indiana, can provide technical assistance. And there's the email, ada@ndot.in.gov, PennDOT, Pennsylvania.gov, ND.gov. Well, we don't have to worry about that with Indy because I'm the guy that's going to be doing the ADA ramps. Now, if an alternative meets the ADA requirements, cannot be found, the project manager here in Indiana, we call it the PEPS, which is the project engineer, project supervisor, or the RPR, should have the designer document the alternatives considered and request a determination of technical inquiry or infeasibility. Changes from previous NDOT practice. Now, designers have been directed to fully detail curb ramps on construction plans. So there is no construction tolerance for cross slope. There is no construction tolerance for running slope. So the standard drawings no longer indicate curb ramps by a letter type. They are identified by configuration. Either they're perpendicular, parallel, blended transition, depressed corner, or diagonal. Now, I'm happy they did that because at PennDOT, we never used letter designations. We always used blended transition, depressed corner, diagonal. You need to know what type of curb ramp that you're inspecting as well if you're going to document it properly. Now, NDOT used to have this 13-page document, and you had to utilize that 13-page document for each and every ramp. So you could have 100 ramps out there, and you have this 13-page document. Now, what I'm going to do is get something and try to utilize it for one sheet of paper, because I'm not going to use the word I believe 13 pages way too much. One page is enough, and we're doing everything electronically anyway. But having the paperwork is a way to document where your ramps are when it comes to compliance. So again, something that you need to understand if you're out in the field, all curb ramps are paid for as a single pay item. Curb ramp concrete. Detectable warning surfaces, which are your truncated domes, are paid for separately. Now, the concrete under the truncated domes as well is also paid for. Don't forget that. Some people might forget that. So just because you put concrete, you might have a little bit of concrete under the dome, but basically that whole area is still filled with concrete. You know, you put the dome on top of it, got to be paid for. Now, this is what I'm telling you right now. The area, so you understand about the concrete, the area of the detectable warning surfaces is not subtracted out of the curb ramp. Concrete quantity, just mentioned that. Detectable warning surfaces retrofit was added as a pay item. So this would be placed where a curb ramp is fully compliant, but it just needs the detectable warning surface added. For example, during construction, now, some cities, yellow paint on curb is no longer required. Some cities still have it. Also, here in Indiana, this is where I see it. Now, in other states like Pennsylvania, New Jersey, we don't use grooves or transverse corrugations. You can, they're not required. But grooves or transverse corrugations on a ramp are no longer required and should not be placed on NDOT projects. Now, if you're doing a city project or an LPA project, they still may choose to place the grooves. I know Indianapolis does. I found that out today. So either way, you can, unless you're on an NDOT project, don't use them on NDOT projects. Use them on municipality projects or here, local public agencies, which is the same as a municipality. And of course, your cities. All right. Leaving a 1/4-inch lip at the edge of the curb for drainage is not legal. Curb shall be built as shown in the drawing during construction. So that's something you might check out. And with these ramps as well, after it rains, right around the curb and gutter, you should check for ponding. You might not think about it now, but in the wintertime, it could freeze up and turn into ice. And then you really have a problem. Compliant or not, this ramp is compliant. The DWS is set on the entire width of the ramp. The DWS is less than 5 feet from the back of the curb. All slopes are less than maximum, and the casting is not within the DWS. And what do I mean by the casting? That's for a manhole or a water meter or a utility. Now, if a casting is placed within the limits of the pedestrian path or ramp area, the warning surface may be placed where you have it right here, shown right here in the PowerPoint. Now, the casting must be completely flush with the path. All right, now, compliant or not. Now, this ramp is not compliant because the casting is in the DWS. You're inspecting, make sure you check that out. I know in the city, I'll be coming around to make sure that you're checking it out. So now, here's what I would do if you have a casting. We can always relocate the casting. And if you also want to avoid the casting, you could shift the curb ramp. Those are your two options. All right, you look at this ramp right here. And let me tell you something else that I have found in this slide that's not compliant. All right, number one, the clear width is less than a minimum of 4 feet. Number two, you see that smart level? We don't use 4-foot smart levels when we're inspecting ramps, unless the specifications call for it. We'll use 2 feet. Now, how would you actually measure 4 feet? Well, you can get a folding 6-foot rule. You could use a tape. You can use a measuring wheel. Now, if there is an obstruction, you move it. Like here, you have a sign. You move the sign. You can remove building curb if curb is not necessary. Okay, you can modify the curb line with the sidewalk bulge out next to on-street parking. That will put this ramp back into compliance. This ramp is not compliant because the DWS, which is the detectable warning surface, and the detectable warning surface has not been provided the entire width of the ramp where it is flush with the street. You see this right here. This is exactly what they're talking about. Options. You can extend the detectable warning surface. You can move the curb transition to remove the flush area not covered by the detectable warning surface. Also, this ramp is not compliant because the detectable warning surface is not at the bottom of the ramp and has been placed greater than 5 feet from the back of the curb. And this is what we're talking about, the back of the curb right here. See, it's greater than 5 feet, bottom of the ramp. Now, you can move the DWS to behind the radius and follow the back of curb where it is flush with the street. Now, what they're talking about is, you see this radius right here? Where you can have your 2 feet, and it can go all the way up there to be flush with the curb. That's what they're talking about. That's what I would do. All right. This ramp is compliant because the DWS is set the entire width of the ramp. So a turning space is provided, and all slopes are less than maximum, and the curb height of 3 inches minimum has been provided between the 2 ramps. Again, see why this ramp is compliant? This DWS covers the entire width of the sidewalk. And of course, you have turning spaces. So all your slopes are less than minimum, and your curb is your turning space right here. Your curb height of 3-inch minimum has been provided between the 2 ramps. Here's ramp 1, here's ramp 2, and here's your curb. It's minimum. And since the curb cut has been provided, a continuous DWS is not required. And generally, when you have a turning space, you don't need it. Because what happens is, remember, when you place these ramps at corners, you must also provide for the drainage, because you don't want ponding on these ramps. One thing you must understand with construction, period, where is the water going to go? And you have to understand the slopes. And water does travel fast, so that's why 2% is required. Generally, your roads have 2% slope from the crown. All right, this ramp, compliant or not? This ramp is not compliant because the inlet is within the crosswalk and the grate is not transversable in all directions. Again, the grate is not transversable in all directions. So to be transversable, the grate openings must be 1/2 inch by 1/2 inch. These are 1/2 inches by 4 inches. And they're talking about the grate openings. So move curve transition. You can change grade or move inlet. Now, replace grade if the NJ hydraulics section approves. Move the inlet out of the crosswalk. You can also skew the crosswalk, shorten the DWS. Now, this ramp is not compliant. Look at the ponding, because there should not be any standing water within the curb ramp area. And after it rains, if you're out there on a job, you need to inspect these ramps. You have all this ponding, and in the wintertime, this will turn into ice because it's going to freeze. Again, you got to work with the grade of the roadway to drain water. You want to drain it away from the curb cut ramp. Now, you have to understand that drainage through any ramp is critical, even if you have 1/4 inch of water ponds. When this turns to ice, just like I said, it becomes a huge safety hazard and liabilities are going to take place. So think about considering elevations at numerous points in order to get your drainage. Again, minimum dimensions are 4 feet by 4 feet. The push button clear space may overlap a curb ramp turning space. So be on the lookout for obstructions such as curb, slopes, guardrail, or unimproved surfaces that may obstruct access to the push button assembly. Again, be on the lookout for obstructions such as curb, slopes, guardrail, or unimproved surfaces that may obstruct your access to the push button assembly. This is your push button assembly. Now, the lowest edge of the object mounted on pole in pedestrian access shall be, that's your pedestrian access route, shall be a minimum of 6.7 feet above the finished surface. That's what they're talking about here. And what I'm going to do, I will see if I can put the link at the bottom of this video when I'm completed this presentation. Now, also getting into your MOT, barrier and the toe. Barrier and the toe plate were used. Now, this is your toe plate. This is your temporary MOT. This is your barrier. This is your toe plate. Again, there's your curb. A ramp is probably going to go in here as well. And if nobody's around here, this should be roped or taped off. That's one thing that I will look at when it comes to inspection. If there's nobody working in that area, it should have some safety tape, some yellow safety tape. Because you want to secure the area to make sure it's safe for pedestrians or close the area. Now, one thing that you must understand too, and this is where all of the sheets come in, you need a curb ramp checklist. And this is the forms, like Pennsylvania uses a CS 4401. NDOT uses their 13-page form. I saw a 19-page form. Well, that's your checklist. And you must compare field conditions to plans before beginning any type of construction. Also, if you're out there inspecting, if you're a new guy out there, or even if you haven't worked on an NDOT job, familiarize yourself with the standards. Now, all work must follow the ProWAG requirements unless an approved technical and feasibility or technical inquiry determination allows for a non-compliance of a specific feature. Also, contact the designer if the curb ramp needs to be adjusted due to field conditions in order to meet ProWAG criteria. And if the plans do not show a pedestrian MOT plan, contact the designer, find out why. And construction sequencing might not be included in the plans or contract information book, but might be necessary. That's when your contractors see what they're going to do about that, their schedule. And also, when checking quality of construction, run slope checks as soon as possible or any given section of sidewalk or specific curb ramp, example, when forms are set. So do not construct most of the project and then begin checking these items. This will allow corrections to be made early and will eliminate the need to remove large amounts of work. Here's what I normally would do. While they're placing in forms, use your smart level so they can get the grade. And once you have the forms at grade, you can pour. That way, you have everything compliant and you don't have to worry about anything being off. Also, how are they pouring the ramps? Sometimes they pour the ramps monolithically, which means they pour them all together. Sometimes they pour them separately. Now, either way, check out the slope of the formwork with the smart level to get that compliance before you pour concrete. Because a lot of times, individuals, they don't check the formwork. You know, if it's up too high, have them take a hammer, tap it down. Again, it's very important that these ramps are compliant. For drainage, you have people using these ramps, even if you don't have a handicap, all part of the sidewalk. And you have to make sure castings will not fall within the limits of detectable warning surface. Now, again, castings that fall within pedestrian path or curb ramp limits must be flush with the surrounding area. Also, check to see if water will pond in a ramp or directly in front of it. And if it does, contact your designer and check counterslope between ramp and roadway. Here's the word I was looking for. If the algebraic difference between the counterslope and curb ramp slope is greater than 11%, got a problem. Contact your designer. Now, here are all the links for all of the specifications. Now, of course, specifications change, but this is generally what you use. Every state has their own. Look up your state's standard drawings, standard specifications. See if they're under the ProWag guidelines. See if you got a field manual and a design manual. It's very, very, very important. ADA information. That's how we do it in Indiana. And that's it. And if you have any questions, put it in the comment section under the video. But again, as we go over ADA, ADA is done under the current ProWag, which stands for Public Rights of Way Accessibility Guidelines, and ProWag guidelines must be followed. And again, if you need more information, I will provide it for you. Bottom line is, we want to make sure that all of the ADA ramps are compliant because we have a number of individuals, whether you're handicapped or not, it's for safety. And if you have an area that's not safe, there is going to be a liability. And once again, that concludes this topic on the inspection of ADA ramps. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some social content as well, you check out my main channel, the 411 Talk Zone Radio Show channel. Now, if you cannot find the 411 Talk Zone Radio Show channel or QCIS channel here on YouTube, you're not in the right place, because after I record all of my videos from both channels, you can find both channels, the 411 Talk Zone Radio Show and the QCIS channel, on my Twitter page. Now, because the QCIS channel is an educational channel, I also post my video content on my LinkedIn page. And let me tell you this. If you're not asking me about something related to STEM, I'm not going to contact you. Okay, this is not a Facebook site. This is a site. My videos are for educational purposes only. And if you're interested in the FB or the PE examination or something mathematical, you can contact me there. But other than that, I don't know half these individuals that are trying to contact me from marketing, accounting. I can do all that myself when it comes to my own business. And I can go to somebody in person if I need some help with Quality Control Inspection Services Incorporated. Now that I got that out of the way, again, I want to thank you all for listening and viewing this content on the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.